In this video, I am going to start how to prepare haloalkane and haloarene. So this is the part 2 chapter organic chemistry part, and this chapter is very important for the board students and for those students who are preparing for competition. So in the previous video, I have explained what is haloalkane and what is haloarene. So now I will start how to prepare haloalkane. The different method for the preparation of haloalkane. The first method that we use is from alcohol. How can we prepare haloalkane from alcohol? The second method is from alkane. The third method is from alkene. Fourth method, that is halogen exchange. Halogen exchange. So these are the four methods. Using these four methods, we can prepare haloalkane. But for the preparation of haloarene, we need electrophilic reaction and Sand-Mayer reaction. That I will discuss after discussing this part. So how can we prepare haloalkane from alcohol? Alcohol group I have already explained. This is the alcohol group. R is the alkyl group and OS is the functional group. So when alcohol is reacted with concentrate acid, when alcohol is treated with concentrated acid, in this case haloalkane, or we can say alkyl halides plus water formation takes place. Suppose in place of R, ethanol is taken. So if ethanol is reacted with concentrate acid, then here ethyl chloride, or it is also called chloroethane plus water, is produced. This is very important reaction because here the R group, that is alkyl group, this alkyl group is 1 degree, 2 degree or 3 degree. So if suppose you have taken 1 degree alcohol, if you have taken 2 degree alcohol, or if you have taken 3 degree alcohol, and in all the three cases concentrate acid is used, a very important reaction. All the cases concentrate acid is taken, then in all the three cases alkyl halides are the products, are very important, but the reactivity of the reaction is different. 3 degree alkyl group is more reactive, 3 degree alcohol is more reactive than 2 degree alcohol, and 2 degree alcohol is more reactive than 1 degree alcohol. So we can say that 3 degree alcohol directly react with concentrate acid, no catalyst, no zinc chlorides are used. See here alkyl halides. But if we take 2 degree alcohol or 1 degree alcohol, here to react these two reactant, we need catalyst ZnCl2, that is zinc chloride, then only alkyl halides are produced. So this is very important reaction, that the reactivity of 3 degree alcohol is more than 2 degree alcohol and 2 degree alcohol is more than 1 degree. This is the question that can be asked in the board exam. Second method is preparation of haloalkane from using phosphorus halide. The second important reaction that we are going to use here, we can use the reagent, that is phosphorus halides, and 3 types of phosphorus halides can be used. The first is phosphorus pentachloride, PCl5. So when haloalkane is reacted with phosphorus pentachloride, in this case, the product is CH3CH2Cl, POCl3 phosphoride chloride plus water. This here phosphorus pentachloride, using this method we can prepare only chloroethane or ethyl chloride. We can prepare chloroethane or ethyl chloride. If suppose phosphorus trihalide is taken, then here X is bromo, chloro or ido we can use. So here product is CH3CH2Cl H3PO3 phosphorus acid, and the last, that is when it is reacted with phosphorus in presence of iodine, then here iodo ethane या ethyl iodide is product formed. This is the product formed. So these are the important reactions that we are going to prepare using this method. Here PX3 we can use chloro and bromo, not ido. And when we are going to use red phosphorus in presence of X2, here in place of I2 we can use X2. Red phosphorus, here red phosphorus in presence of X2, here X is bromo and ido, both we can use using this method. So this is the another method for the preparation of haloalkane using alcohol. Next, if we use SOCl2, this is the best method for the preparation of haloalkane, and here the SO is there, sulfur group is there, so SO2 is the product, HCl is the product, so the main group is CH3, CH2, Cl. So this is the best method for the preparation of haloalkane because its two products, both are gaseous form. So we can easily extract this. So using alcohol, we can prepare haloalkane either using HCl or using PCl5 or using PCl3 or using red phosphorus in presence of X2 and sulfonyl chloride, that is SOCl2. So these are the methods through which we can prepare haloalkane from alcohol. This is the first method for the preparation of haloalkane. Here one thing I want to say that this method is not suitable for the preparation of haloarene. Using this method, suppose here we can use phenol. This is phenol. So we cannot prepare this using this method. We cannot prepare this compound, chlorobenzene. Not possible. Why? Because between carbon and oxygen there is a double bond character. This is double bond character, and due to this double bond character, this reaction is not possible. So using this method only, here aliphatic alcohol we can prepare haloalkane, aromatic alcohols are not used. The second method is from alkane. From alkane we can also prepare, but here one thing I want to say, 1-2 questions has been given in NCERT book, and based on this reaction, that is important. You should know how to solve these questions. There is one question given in NCERT, that is important question. This is the question. Cyclohexanol reacted with sulfonyl chloride. So this is the same reaction that we have discussed just now, COH SOCl2. So here what is the product? I said SO2 plus HCl, and this is C2H5Cl. Same thing it will be here. Chlorocyclohexane plus SO2 plus HCl. So don't forget, this is the same way we can prepare this reaction. Another reaction is given, that is very, very important. Mind it, this is the reaction, very, very important. So that's why I am explaining this part, that, and this is OH group. Suppose this is, so here two OH are there. I said this alcohol only use aliphatic. So this alcohol is going to be preferred. This alcohol is not going to be preferred. It is reacted with HCl. Here the product will be, mind it, this is very, very important information, H2O and here OH group. This is the main product. So don't get confused. This is the here CH2OH. This is the aliphatic part, not aromatic part. It is the aliphatic carbon. Over there OH is going to be attached. Aromatic carbon is not going to attach with OH, but this OH is going to attach with aromatic. So this reaction is not possible. This OH is not going to react. Only this part of OH is going to react in this reaction. So this is very, very important reaction. That is for the preparation of haloalkane, and we have just changed the reagent. That reagent carrying aromatic groups or cyclo group. So get sure that here aromatic part is not, OH should not be attached with the aromatic part. Second is the from alkane. Alkane, that is, suppose you have taken methane or ethane. If it is reacted with chlorine in presence of sunlight, this is also called free radical reaction. This is called free radical reaction. Here one thing I want to say, alcohol group or alkane group single bonded compound normally gives displacement reaction, or you can say that substitution reaction, whereas double bonded or triple bonded compound normally gives addition reaction. So an elimination reaction also we get in single bonded compound. Here multiple products are produced. Here the reaction will continue unless or the entire H group is replaced, and we get its isomeric form also. Suppose this is the compound, this is propane. So here we get monohalo or multiple of the product. This is the product. This is the product. So here the two isomers we can get, both are isomers. Here the reaction is C2H5Cl, C2H4Cl2, C2H3Cl3, C2H2Cl4, C2HCl5, and the last is C2Cl6. So mixture of the products are produced. That's why this method is not suitable for the preparation of haloalkane, or we never use this reaction. Third is from alkene. Mind it, alkene is a unsaturated compound. Here double bond present, and whenever there is a double bonded compound, we can use, here this is the double bonded compound. Suppose this is a reagent, and if it is reacted with, suppose HCl, then in this case, this double bond, here two bonds are there, one is the pi bond, one is the sigma bond. So pi bond is a weak bond, so this pi bond is broken, and in place of one pi bond, mind it, for one pi bond, two new bonds are produced. Two new bonds, very, very important. So we can say that here CH3, CHCl, CH3. Here the reagent will break into two parts, H plus and Cl minus, and the reaction will be controlled by a reaction. That reaction is called Markovnikov rule. Very Markovnikov rule. Markovnikov rule. Very important. Very important. According to this rule, when a reagent is attacking a unsaturated compound, double bonded compound, the negative part of the reagent will attack that carbon, double bonded carbon, which has least number of hydrogen atoms. So here this Cl will attack this carbon. So this is the main product. Here one more product can be formed, but the major product is this CH2, CH2, Cl. This is the minor product and this is the major product according to Markovnikov rule. Next part is, suppose this is the ethene and it is reacted with bromine. This is a very important reaction, test of unsaturation. This is the test of unsaturation. Here vicinal, Vicks dibromoethane is produced and reddish brown precipitate discharged. This is a very important information. The reddish brown precipitates discharge. So we can say this dibromo halides, or its IUPAC name is 1,2-dibromoethane. 1,2-dibromoethane. So this is the reaction which is test for unsaturation. Unsaturated compound, double bonded compound, its reddish color gets discharged. So this is a method for the preparation of alkene. Then here reagent is CCl4, carbon tetrachloride. That is important information. Here 1,2 reaction is given in NCERT book that we have to discuss. This is very important. Based on this reaction, NCERT questions, some questions are given. So whenever you get such type of question, just I am suggesting you, advising you, get sure that which type of reagent is given and accordingly you give the product. Don't get confused, just see the reagent. The reaction is given here. This is the product. This is the product. Here H plus HBr. This is the first reaction. Second is CH3CH2 CH double bond CH2 plus HCl. Third is this here HBr, but one word is mentioned here, that is peroxide. That is important. Nothing is mentioned, that is it will go according to Markovnikov rule. So it will break H plus and Br minus. Negative will attack that carbon which has this number of hydrogen. This is the part. So you can see that this here this bond is broken. So you can write like this. Here C6H5. This phenyl group can be written like this also, or you can directly write with phenyl group also. No issue. This is the point. Here H and here one more Br group and this H group. This is the product. Simple Simple, this pi bond, you need to break this pi bond to new bond formation. Don't see what is given here. Don't get confused. This part is not important. Only the double bond is important. Here one bond is broken and two atoms, two new bonds are formed. So the carbon which has, and nothing is given, that means carbon. The carbon which has least hydrogen, here one hydrogen, here two hydrogen. This carbon will have, it has least hydrogen. So here Br will attack. In this part, this is going to be important. This part is not important. So thus this is the CHCl and here CH3. Mind it. Negative part will attack that carbon which has least hydrogen. Peroxide is opposite to Markovnikov. This part is important. Mind it, this part is not important what is given. Phenyl group is given, aromatic group is given, that is not important. You just need to focus what is the reactant, the main part. This is the main part. So peroxide tells that it is just opposite to Markovnikov. Negative will attack that carbon which has maximum hydrogen. So here this is the hydrogen will attack here and here single bond CH2 Br and this bond CH2 this one. So these questions according to Markovnikov rules, and anti-Markovnikov peroxide is also known as anti-Markovnikov rule. This is also called anti-Markovnikov rule. Very, very important. This is very, very important. Be careful when such type of questions are given in the board exam or in the competition exam. Next part is from halogen exchange. Halogen exchange. Here, from halogen exchange, two reactions are given there. One is, suppose Rx, and here NaI, here X, in place of X is chloro or bromo. Second reaction is given, here RBr plus AgF, silver fluoride. This is the very, very important reaction. The first reaction is here dry acetone. Here dry acetone is going to be used. That is when haloalkane is treated with sodium iodide, here halogen group is either chloro or bromo, then in presence of dry acetone, then it will be Ri, that is iodoalkane plus NaX, and here idofluorine or AgBr. So depending upon the reagent, this reaction has been given different name. The first one is called Finkelstein reaction. Finkelstein reaction. The first one is called, very, very important, this is Finkelstein reaction. Very, very important here for the iodoalkane. And this is fluoroalkane. This method is called Schwarz reaction. Here reagent must be either AgF or Hg2F2, mercurous fluoride, or cobalt fluoride, or it is antimony SbF3. So these are the reagents we can use here, and this reaction is called Schwarz reaction. Very, very important reaction. In the board exam, if the reaction has been given its name, mind it, those questions, those examples, those reaction whose name has been given, that reaction is going to be very, very important from board's point of view. So you must remember that this is the halogen exchange method is very, very important because its name has been given. Finkelstein reaction, we can use sodium iodide in presence of dry acetone, and here chloro or bromo are replaced by iodo group. And in second case, silver fluoride is used. Silver fluoride is used, or these reagents are used for the preparation of fluoroalkane. This is the best method. So we can use chloro, bromo, iodo using alcohol, but fluoro or iodo we can use Finkelstein or Schwarz reaction. This is a very, very important reaction. After that, there is one reaction given here in the NCERT. After that, one more reaction is left, that is for the preparation of aromatic haloalkane. This is aliphatic. And for aromatic haloalkane, two important methods are given: electrophilic substitution and Sandmeyer reaction. Sandmeyer reaction is a very, very important reaction, very, very popular reaction, where diazonium salt is going to be used. Here we are going to use diazonium salt. So here aryl halide. And two methods we are going to use. First is the electrophilic substitution. Electrophilic substitution. And second is the Sandmeyer reaction. Very, very important. In this reaction, benzene or benzene derivatives, suppose toluene, is reacted with halogen group. This X can be chloro-bromo group, chloro or bromo group, in presence of Lewis acid, that is FeCl3. So here two products are produced. Very, very important reaction. Here incoming reagent is, that is halogen group, either on ortho position or it will come on its para position. This is orthochlorotoluene. Orthochlorotoluene. This is parachlorotoluene. So mixture of these two products are formed, which can be separated very easily because they have boiling point, they have large melting point difference. Large melting point difference, so they can be separated very easily. So either FeCl3 or AlCl3 we can use as a Lewis acid for the preparation of haloalkane. Second method, that is Sandmeyer reaction. In this reaction, primary aromatic amine, it is also called aniline, is reacted with nitrous acid. Nitrous acid can be prepared when sodium nitrite is taken with HCl. So a product is formed that is called diazonium. And this method is called azotization. This is diazotization. This is diazonium method. This is diazonium dye product. This diazonium, when treated with copper 1 halide group, that is CuCl or CuBr, then here suppose CuCl it is taken, then here chlorobenzene is produced. If CuBr, here in place of HCl we have taken HBr, so here it is better to write HX, here HX. If CuBr is taken, then bromobenzene. Very, very important reaction. This is Sandmeyer reaction. So using this reaction, we can prepare aromatic amine. Here nitrogen is also the end product. This is the important reaction. So these all are information that is given related with preparation of haloalkane and haloarene. I am dividing the topic in different parts. In the first video, I explained what is halo group, that is aliphatic groups and aromatic groups, their hybridization, their bond length, their nomenclature, their physical properties. In the second part, I have given how can we prepare the aliphatic group as well as aromatics group, and in the next video I will give the chemical properties and the chemical reaction of these compounds and some question related with NCERT book and all the entire conversion. For example, there are 1-2 conversion I want to explain. This is very important for the board students also. Board students often confused. They are having problem related with, suppose there is a question, how can you convert propene to propane 1-ol? There is a question, propene, this is propene and we have to convert propane 1-ol. So here we add water. This is easily converted into using anti-Markovnikov. We can get propane 1-ol. So we will discuss all these things in detail in the next video, and the different techniques that are going to explain the conversion part. So here what is actually double bond is there and OH group introduced. You can use aqueous KOH also, but aqueous KOH cannot be used because there is no halogen groups. So we can either convert this double bond to halo group that I have explained. You can either convert this double bond to single bond, that is adding HCl, anti-Markovnikov or peroxide effect. We can do this. Halo group, aliphatic, and then aliphatic halo group, and then we can convert into alcohol group. So that conversion part I will explain in the next video and its properties part. Thank you.